Namaskar, I am Dr. Deepti Gupta. I am an architect, project manager and engineer. I am practicing under the name PNG Design Consulting and I also teach at the School of Planning and Architecture, New Delhi as a visiting professor. I welcome you all to this module called Integration of Services with the Structural Systems in a Large Hospital. First, we need to know what are building services. Building services are the systems installed in buildings to make them comfortable, functional, efficient and safe. They are commonly referred to as MEP systems, meaning mechanical, electrical and plumbing. In the larger buildings, fire safety becomes a big issue, so they can also be called MEPF services, including fire safety. Building services play a central role in contributing to the design of a building. The building service design must be integrated into the overall building design at a very early stage, particularly in complex building projects like hospitals. Now, building services include electrical services, which means energy supply and distribution, lighting, plumbing, which includes water supply, drainage and plumbing, sewage disposal, fire safety, which includes detection and protection by firefighting and timely egress, HVAC, which is heating, ventilation and air conditioning, escalators and lifts, security and alarm systems, building management systems, and so on. Some of the specialized building services required specially for hospitals would also include systems for bacteria and humidity control, emergency power, specialist gas distribution, radiology labs with special provisions, operation theatres and so on. In a hospital, the most important factor is the safety of patients. This includes general safety, safety of the patients who are not mobile or are on life support, safety in case of fire, safety from the point of health and hygiene, avoiding cross-contamination at every cost. Ease of access and egress for patients is also very important. The hospitals and their services are designed as per NABH guidelines and the other relevant codes. When it comes to integration of the services within a structure, it is useful to look at the services not only in isolation but in the context of the spaces they occupy in the building. As a designer, planner and architect, it is important to know where and how various components of the services are incorporated in the building. Accordingly, the required spaces are provided in the building complex by the architect for the services. First, we shall discuss the electrical system. The major categories of the electrical system are supply, distribution and lighting. For electrical system designs too, the design parameters are set in accordance with the codes. These are the minimum requirements that must be met. The electrical system works like this. Electrical supply to the campus would be in high voltage supply to the tune of 11, 33 or 66 kV. The main supply to the site is by HT cables. At the gate or at a nearby easily accessible location, the meter is located. From there, it goes to the substation, which is also best located at the periphery. The substation houses the HT panel and the transformer, which converts the power from high voltage to low voltage that can be used, for example 1100 by 415 or 33 by 415 as per the connection. Electricity is distributed and managed to the LT panel room in the campus. So the main components of an electrical system can be seen in this diagram. The components on the left side indicate the high side like the transformer, HT panels, generator, etc. And the ones on the right side show low side of the electrical components like the LT panels, distribution boards, internal wiring, etc. Lighting fixtures and sensors are also a part of this. Now, in order to make a green building and to save electricity, lights controlled by occupancy sensors are used. The transformer room may be located in the basement provided there is earth below. It is not acceptable to provide another level of basement below it. It is possible to position it on the ground level, but again it must be directly on the ground and no building or basement may be below it. Earthing is required for transformer room. Now the LT room may be in the basement and requires a double height. The electrical room houses LT panels and it is the main power supply center of the building. From LT panels, electricity is supplied to the whole building through cables. These cables have a relatively large diameter and are many in numbers. So for the purpose of maintenance, they are not embedded in the civil works like we do in normal buildings. Either they are laid on cable trays, suspended from the ceiling, or are clamped to the ceiling. The electricity is distributed to the floor panels located at each floor through vertical shafts and then sub-distributed to each area. The meters for monitoring electrical consumption in each area may be provided on each floor panel or in the LT panel itself. All critical areas have their own individual floor panel for electrical and their individual uninterrupted power supply or UPS, which is connected to a centralized UPS. Power backup for all essential services have to be provided. Generators are needed to provide a power backup. Due to the critical nature of life-saving equipment used in a hospital, the automated power resumption time has to be minimal and should not exceed a few seconds. DG room or the diesel generator room may be located in the basement provided that there is no building immediately above it and no other building is located above it. It needs acoustic provisions due to vibrations. We use dense pads and isolated springs to absorb vibrations and sound. Its exhaust system should be independent. Fumes are exhausted to the terrace via DG flue pipes. In the diagram here, we can see the generator being fed by the diesel pipes, the flue pipes for exhaust and its sink panel. Fire safety provisions for DG rooms are to be made adequately. If people remember the tragic fire of Upahar cinema, which consumed many lives, is believed to have started with the DG. Now the DG will have its own DG sync panel, means DG synchronization panel. The power from DG is collected at this panel and distributed to each area as per requirement. So it is used for sorting the current before distribution. Unlike regular buildings, in a hospital building, the conduits are not embedded in the civil work to ensure easy accessibility for maintenance. Cables are laid on cable trays which come under the ceiling and may or may not be covered by a false ceiling. If the basements are being used for parking, electrical points for car charging should be provided. Now we come to plumbing systems. Plumbing includes water supply and drainage of waste as well as rainwater. The plumbing system consists of three major categories: gravity drain waste systems, pressure driven systems which are called hydropneumatic, and pumped waste system. Water tanks for all purposes including water supply and fire as well as fixing of all plumbing fixtures is included in plumbing services. As we see in the slide, water supply can be done either by a combination of underground and overhead tanks and then using gravity for water supply. Or another option is that there is no overhead tank. The water is supplied in the building from the underground water tank, which is supplemented with a series of pumps to maintain the required pressure. A hydropneumatic system is a domestic water supply system in which water is pumped from the supply system into a pressure tank for storage. Air in the tank is compressed by the water entering the tank. As the pressure in the tank increases, the pressure in the water distribution system also increases, since it is fed from the tank. In a green rated hospital building, it is recommended to have a zero discharge building. A zero discharge building means that no water is sent out of the hospital site. The water discharged as kitchen and toilet waste is sent to an on-site sewage treatment plant called as STP, where the water is treated and used for the purposes of toilet flushing, horticulture, washing, makeup water for cooling towers. The solid waste generated is used as manure. So now a dual piping system is required in the toilets so as to provide fresh water for hands washing and hygiene faucets in the bathrooms and for kitchen, etc. Rainwater harvesting. So when we talk of rainwater harvesting, it is not only important for conservation of water, it is also mandatory by the law. Hospitals now need a hot water for a variety of functions and hot water pipes from boilers are spread across the building for supply of hot water wherever required. Steam boilers, which are placed in hospitals, are used for various purposes like heat and humidity control, which is a part of HVAC. Then another important thing in hospitals is sterilization. Hospitals use a wide array of medical tools and instruments which need to be sterilized. A portion of the steam produced by boilers gets pumped into an autoclave sterilizer, which is usually located in the lab or surgical area. The hot steam helps to kill any germs and bacteria on medical tools. There is one central sterile service department called as CSSD for the whole hospital. Next use of boilers is laundry. Hospitals do massive amount of laundry on a daily basis. All the gowns, sheets and towels they use need to be completely free of germs. So one dedicated autoclave unit is provided for disinfection of laundry from the operation theatres only, and the rest of the hospital is separate. Kitchen and toilets. Now cooking and cleaning in a hospital kitchen requires a lot of hot water, and so do toilets. So accordingly, plumbing points are to be provided for hot and cold water in all the zones where hot and cold water are both needed. Pump room for plumbing is placed in the basement. It requires a double height to accommodate all the equipment that is there. However, according to the codes, it may not be placed any lower than 6 meters below the ground level. Pump room has all the water tanks, including the fire tank. The fire tank is always kept full and the water is not used for anything else except for a fire emergency. To avoid stagnation of this water, the inlet water comes first into the fire tank and then the overflow goes into the other tank for water supply. Sometimes if the quality of water is below par, we may use water softeners and filters to treat the water before using. Now drainage. So for drainage in the basement, surface drains which are covered with slotted grills are provided. The drained water is collected in a sump where a pump is used to discharge the water into a riser at the ground. 2 sump pumps are used. One is working and one is a standby. Generally, we provide one sump for every 2000 square meter area, and the sump of approximately 1.5 meter by 1.5 meter by 1.5 meter would generally be adequate for 2000 square meters. In a zero discharge facility, we have to provide STPs and ETPs within the site. STP is sewage treatment plant. It treats the water from the toilets and kitchen. It would have 3 levels of filtration: primary, secondary and tertiary. So adequate space has to be provided for STP. If the filtration system is inadequately designed, it can lead to unclean water even after treatment. Next is ETP or effluent treatment plant, which is a most cost-effective and technically proven system to remove the unwanted hazardous chemicals from the wastewater to meet the statutory pollution control requirements, especially for hospitals. The STP and ETP may be outside in the setbacks or in the basement, but with proper exhaust system. The next system that we will discuss is the fire safety system. The purpose of fire protection systems is to make the building fire resistant and to facilitate the speedy evacuation of occupants in the event of a fire. The 2 steps in fire safety are fire detection and firefighting. So for fire detection, we use smoke detectors or heat sensors. For firefighting or protection, we can use systems like firefighting by use of sprinklers, extinguishers, fire hoses, etc. And equally important is evacuation in case of fire. So speedy egress of the occupants is of essence. To ensure that, it is must for the management to conduct regular fire drills as per the norms, so that in case of a fire, people are familiar with the exit routes and are able to exit safely without panic or stampede. For fire detection, we use addressable detectors with smoke or heat sensors. They have an individual IP address that allows us to identify the detector that has picked up smoke at any coordinate of the building. Drawings of each floor are fed into the BMS, including the location of all the smoke detectors. Network of smoke detectors runs across the building. The system is supplemented with manual call points at every interval. This whole network is managed with the help of BMS or Building Management System, which we will talk about later. For fire protection, we talk of firefighting and evacuation. So, sprinklers is the first thing. Hospital building is to be provided with a network of sprinklers on each floor at regular intervals. Water is pressurized with the help of pumps that are attached to the underground water storage tank. We have to also use fire hoses. Adequate numbers of fire hose reels are to be provided on every floor. Fire hose cabinet or FHC, which house the wet risers, are also located as per the fire circles. An easy thumb rule is to provide one fire hose cabinet near every fire staircase. Directional sounders. In case of fire, escape routes are clearly denoted, and for easier evacuation, sound is also used. The destination point has an alarm so that one can find his way if there is smoke. Pressurization is done for stairwells, lifts, lobbies and corridors. They have to be pressurized at the time of fire. So, pressurization shafts are designed next to each staircase and lift lobby. Refuge areas. Now we provide refuge areas which are like large balconies on all sides, so that people who cannot be immediately rescued out of the building can stay in that refuge area for some time. NBC suggests a refuge area after every 3 floors in a high-rise building. It's extremely important to provide fire exits and staircases in adequate numbers. They have to be clearly marked as fire exits as per the National Building Code. There is a maximum allowable distance to a fire staircase from any given point, which is given by the NBC. This can also be marked by drawing the fire circles. Fire exits are pressurized and protected by fire doors with a fire rating as per the code. It is best if the fire staircase can lead directly to the outside or is at least naturally ventilated. Fire safety provisions in the basement are very important. The largest allowable single area anywhere, especially in the basement, is 3000 square meters, so as to prevent the spread of fire and smoke in large areas. For areas larger than that, we do compartmentation. Compartmentation can be done by the use of a water curtain. Open nozzles are placed at a periodic distance along the separation line. They are fed from the fire pump room. In case of fire, they are activated and form a water curtain, thereby separating the 2 zones. The fire or smoke are not able to spread from one zone to the other. Fire tanks and pumps are in the pump room as described before. The pressure is maintained by jockey pumps. For fire lines, the jockey pumps are used to maintain pressure in the fire sprinkler lines. We need 2 pumps, one working pump which runs on electricity and one standby pump that runs on diesel. Jockey pumps maintain pressure in the sprinkler lines and the hydrants, which are provided in the fire hose cabinet. Wet risers are from the underground fire tank to all the upper floors. The pressure is maintained, so they are called wet risers. There is also a system where downcomers from the overhead tank come down to all the floors, but this is not recommended for a large hospital building. If the basement is over 200 square meter in size, sprinklers are to be provided there too. For an architect, planner or designer, compartmentation is perhaps the most important element to be incorporated in a hospital design. Maximum single area allowed is 3000 square meters, otherwise it should be compartmented. Compartmentation of all critical areas with fire rated walls and fire doors etc. every 750 square meters. If there is a hall, curtain walls can be used which slide up to the ceiling and come down in case of a fire. Smoke extraction system is also required. Compartmentation is also discussed in the HVAC system separately. For evacuation in case of a fire, we also need fire lifts. Some of the lifts are designated and marked as fire lifts. They are operated with the fireman switch only by the firemen. Now we have to also seal the shafts. Shafts have to be provided for travelling of services. Now these very shafts, ducts and cutouts provided in the structure also end up providing easy passage for smoke and fire in case of a fire. Therefore, they have to be carefully planned and sealed properly to achieve proper compartmentation and fire safety. The sealing system of all vertical shafts, horizontal shafts, etc. has to be there, as these air cavities may be a good way for the smoke to travel. It may be noted that in most fires, more deaths occur not due to burning by fire, but smoke asphyxiation. For fire safety of patients on life support like CCUs, there are different methods. We have to use, these people cannot be moved out. So we have to use fire-rated doors, and we have a system of smoke extraction in those areas itself. These patients will be kept inside there till the fire is taken care of or is completely subdued. So the HVAC system is designed in a way that it will continue to get fresh air and the smoke will get exhausted out, apart from the fact that the doors are also fire rated, so the fire cannot come in. One important point to note is that even the cabling in the exhaust system has to be fire rated. Otherwise, the cable itself will burn out and the system will not be effective anymore. This brings us to the end of this part of this module. Thank you. Namaskar.